Hello students, again welcome to first PUC classes. As we are discussing the NCERT numerical in the previous class, let us continue the next numerical of NCERT. The numerical is a brass wire 1.8 meter long at 27 degrees Celsius is held taut with little tension between the two rigid supports. If the wire is cooled down to a temperature minus 39 degrees Celsius, what is the tension developed in the wire? If the diameter is 2 millimeter and the coefficient of linear expansion of the brass is 2 into 10 raised to minus 5 per Kelvin and Young's modulus is 0.9 into 10 raised to 11 Pascal. See here, a wire is fixed between two rigid supports. A brass wire of length L, 1.8 meter L, fixed between two rigid supports. If it is cooled down, it gets taut. When temperature increase, it expands. When cooled down, it becomes taut. When contracts. See here, what is numerical here? Shall I go for the given values? A brass wire of length L. See here. Shall I go solution here? Solution. Brass wire of length L. How much? 1.8 meter. 1.8 meter at the temperature 27 degrees Celsius. 27 degrees Celsius. Held taut between two rigid supports. If it is cooled down, cooled down means the temperature changes from T0 to T. How much? Minus 39 degrees Celsius. Cool down. What is the tension developed? Tension means thermal force. Tension means directly thermal force developed between two rigid supports. If the diameter how much given? Diameter is equal to 2 mm. 2 mm means 2 millimeter, like this. The coefficient of expansion of brass, alpha value given. Alpha value. How much alpha value? 2 into 10 raised to minus 5 per Kelvin. And Young's modulus 0.91 into 10 raised to 11 Pascal. Right? See here, like this. I need the thermal force developed in the rod. Look at me. We know that according to Hooke's law, already we have studied in theory part, the stress is directly proportional to strain, or stress by strain equal to constant. Right? See here, how to take? Y is equal to stress divided by strain. Stress divided by strain. Right? See here, stress means force developed per unit area. Strain means change in length divided by original length. Original length goes upside. From this, how to write thermal force? Thermal force F is equal to how to write? Area into A into del L whole divided by how much? This is L value. Thermal force F is equal to Y into A del L divided by L. Right. Shall I call this equation number 1? Equation number 1. But students, when temperature cool down, length also changes according to this relation. What relation? Change in length equal to original length into change in temperature into constant alpha. Right or wrong? Or from this again, change in length divided by L equal to how much? Alpha into delta T. Now shall I call it is equation number 2? See here, very simple. Just put equation 2 in equation 1. What you are going to do here? Look at me here. Put equation 2 in equation 1. You can solve it very easily. See here, F is equal to Y. Y keep it up same. Area also keep it up same. Right? Del L by L is equal to alpha into how much? Delta T. Right? Again you can write area of cross section of the wire. How much? Area of cross section, it is phi r square. Alpha kept the sum, delta T mean final temperature minus initial temperature. Right? Like this you can write. Again say here, you know all the values. Here diameter is given, but radius is equal to how much? Radius is equal to diameter by 2. Diameter is 2 mm. Then here 2 divided by 2. 2 divided by 2. How much r is equal to? R is equal to 1 mm, 1 millimeter, millimeter 10 raised to minus 3. R value available, Y value is given, alpha value given, T minus T and also given. Then you can calculate thermal force developed in the rod. Shall I take this equation? F is equal to Y. Y value already given. How much? Y value is equal to 0.91 into 10 raised to 11 Pascal. See here. Phi value how much? 3.142. R already given. Radius of the wire 1 into 10 raised to minus 3 square, 1 into 10 raised to minus 6. Right. Alpha. What is alpha? Already given in the alpha 2 into 10 raised to minus 5. 2 into 10 raised to minus 5. T minus T naught. T is how much? Minus 39. T naught how much? Minus 39. See here. 27 is T naught. 39. Then how to calculate? Here T minus T naught, shall I take it is minus 66. See here 40 minus 66 I am getting. Then calculate all the values here. See here. Minus 6 minus 5 minus 11 minus 11 plus 11 get cancelled. Shall I take now? 0.91 into 3.142 into 2 into minus 66. Now calculate all the values, you are getting like this. The force developed equal to minus 377.4 Newton. This much thermal force developed. Then what is minus sign indicates? The minus sign indicates the thermal force is developed inward the given rod, not outward. Here minus indicates simply the thermal force. Thermal force means tension. Whatever tension developed in the rod, the tension always acting towards the inward of the metal rod. So this is the solution for this numerical. Copy it. We will go the another numerical. Just copy it. Right. Shall I take for the one more numerical? Look at me, one more numerical. Shall I go here? Numerical number next one. Look at me. Very simple. Let us go here. Numerical is the coefficient of volume expansion. Coefficient of volume expansion of glycerin is 49 into 10 raised to minus 5. 49 into 10 raised to minus 5. What is the fractional change in density for 30 degree rise in temperature? Question is very simple here. In Kotanri, the coefficient of volume expansion. Coefficient of volume expansion means gamma. Coefficient of volume expansion is 49 into 10 raised to minus 5 per Kelvin. What is the fractional change in density to rise the temperature? How much? 30 degrees Celsius. Right? Fractional change in density I need. Students, already we said that the density of the material changes with the temperature. Volume expansion of glycerin. Glycerin is a liquid. Right? When temperature increase, the density of the liquid must be decreased because due to expansion of volume. We know that how the density changes. The change in density can be given. See here. The change in density is equal to rho naught equal to R. Rho naught equal to how much? Rho into bracket 1 plus gamma into delta T. What is rho naught? Initial density. What is rho? Final density after change in temperature. Or from this how to write? Rho naught divided by rho equal to 1 plus gamma into how much? Delta T. Right? Or shall I represent this? Rho naught divided by rho minus 1 equal to how much? Gamma into delta T. Or I can write rho naught minus rho divided by rho equal to how much? Gamma into delta T. rho naught minus rho, change in density. Change in density can be represented del rho divided by rho equal to how much? Gamma into delta T. See here, this ratio I can call fractional change in density. Fractional change in density means the change in density to original density at given temperature. See here then, again from this how to write. See here, the fractional change in density equal to gamma into delta T. Gamma into delta T. Just solve it. How we are getting? Look at me here. From this again fractional change in density, how to write? Fractional change in density gamma value. Already gamma value is given. How much gamma value? It is 49 into 10 raised to minus 5 per Kelvin. Look at me. See here. 49 into 10 raised to minus 5. Temperature how much? 30 degree. Then the fractional change in density is there. Just calculate it. How much value you are getting? The value is 1.47 into 10 raised to minus 2. 1.47 into 10 raised to minus 2. It has no unit. This has no unit because density by density get cancelled. Kg per meter cube get cancelled. This is one of the numerical. Now let us move for another numerical. See here. Let us go for another numerical. See here, next numerical. Look at me. Numerical number. See here. Numerical number 9. Question is, a 10 kilowatt drilling machine is used to drill a bore of a small aluminium block of mass 8 kg. Right? How much rise in temperature of the block in 2.5 minutes? How much rise in temperature in 2.5 minutes? Assuming 50% of power used up in heating the machine itself or lost to the surrounding. The specific heat of the aluminum given 0.91 joule per gram per Kelvin. Ready? One heating machine ada ಎಷ್ಟು kg ನ heat ಮಾಡಿವಿ? ಅಲ್ಯೂಮಿನಿಯಂ ನ 8 kg ಅಲ್ಯೂಮಿನಿಯಂ heat ಮಾಡಿವಿ, ಒಂದು ಹೋಲ್ ಅನ್ನು ಡ್ರಿಲ್ ಮಾಡಿವಿ. ಎಷ್ಟು ಮಿನಿಟ್ ಒಳಗ? 2.5 ಮಿನಿಟ್ ಒಳಗ. ಹಂಗಂದ್ರೆ 2.5 ಮಿನಿಟ್ ಒಳಗ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ರೈಸ್ ಆಗ್ಯದ? ಏನು ಕೊಟ್ಟಾನು? ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಕೆಪಾಸಿಟಿ ಕೊಟ್ಟಾನು, ಮತ್ತು ಆ ಮಷೀನ್ ಎಫಿಷಿಯನ್ಸಿ ಕೊಟ್ಟಾನು. ಎಷ್ಟು ಎಫಿಷಿಯನ್ಸಿ? ದಕ್ಷತೆ ಕೊಟ್ಟಾನು. 50% ಕೊಟ್ಟಾನು ನಮಗೆ. See here. Now let us go for solution. Before the solution, I will write the given values. What are the given values? Given values. What value given? A 10 kilowatt drilling machine. Kilowatt means power. See here. Power of the machine given. How much power? 10 kilowatt. 10 kilo. Kilo mean how much? 10 raised to 3. Kilo mean 10 raised to 3. Right? Mass 8 kg. Convert this into gram. 8 into 1000. Shall I call? 8 into 10 raised to 3 gram. Right? Efficiency given. How much efficiency? 50% efficiency given. 50% efficiency. Right or wrong? Then I need to calculate rise in temperature. Rise in temperature in 2.5 minute. 2.5 minute. Convert this into second. Multiplied by 60. What are getting? How much? 150 seconds maybe. Right? I need rise in temperature if specific heat capacity given. Specific heat capacity how much? 0.91 joule per Kelvin per gram. Right? These are given values. Andra one drilling machine ada, ಆ ಡ್ರಿಲ್ಲಿಂಗ್ ಮಷೀನ್ ನಾವೇನು ಮಾಡಿವಿ? ಒಂದು ಅಲ್ಯೂಮಿನಿಯಂನ ಹೀಟ್ ಮಾಡಿವಿ. 2.5 ಮಿನಿಟ್ ಒಳಗೆ ಅದರ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ? How much the temperature is increased? See here. We know that the power definition. Actually power is equal to energy divided by time. Energy mean amount of heat energy here. Shall I replace? Power is equal to energy. Energy divided by time. Or what amount of energy available? power into time is available, right? But efficiency given here, so I want to multiply by efficiency. Then shall I calculate here? Q is equal to how much? Power keep it up same, T also keep it up same, or shall I put the values here? Look at me, P is how much given? 10 into 10 raised to 3, how much? 10 raised to 4. T, 150 second. Efficiency how much given? 50%. 50%. Convert this into values. Then shall I take here? Q is equal to 10 raised to 4 into 150 into how much? Efficiency can be converted into values. Divided by 100. Right? Then how much amount of energy given? Q is equal to how much? Q is equal to 150 into 10 raised to 4 whole divided by how much? 2. Right? Shall I call this equation number 1? I will call equation number 1. But amount of heat energy depends on mass, depends on change in temperature. Amount of heat energy depend ಆಗ್ತದ, mass depend ಆಗ್ತದ, change in temperature depend ಆಗ್ತದ. Now shall I calculate here? The amount of heat energy already I have learned. The amount of heat energy can be given Q is equal to mass C into change in temperature delta T. Right? Then see here. Q is equal to mass already given. What amount of mass? 8 into 10 raised to 3 gram. 8 into 10 raised to 3 gram. See, specific heat capacity 0.91. 0.91 into delta T. Now shall I calculate equation 2? Here also amount of heat energy, this also amount of heat energy. Just compare equation 1 and 2. Here also heat energy, here also heat energy. Just I want to compare it. How to compare? 8 into 10 raised to 3 into 0.91 into delta T equal to this value. How much? 150 into 10 raised to 4 whole divided by 2. Right? See here, again from this delta T, how to write? Delta T, rise in temperature, 150 into 10 raised to 4 whole divided by 2 into 8 into 10 raised to 3, 10 raised to 3, 10 raised to 3 into 0.91. Right? Then the change in temperature can be obtained. The change in temperature can be obtained of the order 103 degrees Celsius. Of the order 103 degrees Celsius. I mean, in a 2.5 minute, the temperature of the aluminium will be increased by what amount? 103 degrees Celsius. Again copy this, move for another numerical. Okay. Next numerical is, see here. Shall I go for the next numerical? This is numerical number 9. Now shall I go numerical number 10? Look at me. What is the numerical? A copper block of mass 2.5 kg is heated in a furnace to a temperature 500 degrees Celsius. Then placed in a large ice block. What is the maximum amount of ice can melt? What is the maximum amount of ice can melt? If specific heat is given and latent heat of water is given. Question is very simple here. See here, what is given? A copper block of mass 2.5 kg. 2.5 kg is given. When temperature rises by 500 degrees Celsius, placed on ice block, what is the maximum amount of ice can melt? I mean, a hot material placed on the ice is melted. Generally, he asking how much amount of ice is melted. Very simple. Shall I go for solution? Directly I will go for solution. Given values I will write. Mass is given Mass is given. How much mass is given? 2.5 kg. 2.5 kg, or convert this into gram. Multiply by 1000. 2500 gram. Right? Temperature rises by what amount? Delta T. It is 500 degrees Celsius. 500 degrees Celsius. What are given values? Specific heat capacity given. How much specific heat capacity? 0.39 joule per Kelvin per gram. And latent heat of water is given. How much latent heat is given? 335 joule per gram. I need what is amount of mass melted. Amount of mass melted. Right? We know that the amount of heat energy given. See here. What is amount of heat energy? Amount of heat energy is equal to mass specific heat capacity into change in temperature. Are you following me? Right? Then see here, all values are given. Mass is given, C is given, change in temperature given. How much mass is there? 2500 gram. Change in temperature is 500. What is specific heat capacity? It is 0.39. Right? Then just calculate it. What is the Q amount of value? See here, the Q amount of value is 487500. 487500 joule, like this. Right? Then see here, how much latent amount of heat is available. We know latent heat. Latent heat definition is amount of heat required to melt the unit mass. To melt the unit mass. Again I will take mass is equal to Q divided by L. Here Q is given, latent heat is given. Q is given also, latent heat is given. Shall I take here Q? How much? 487500 divided by L. L already given. Latent heat 335. Then the mass melted is given 1.45 kg. 1.45 kg. Initially it is comes in gram. Just convert it into kg. See here, actually it is 1455 gram will come. 1455 gram will come. Just convert into kg. Then you will get, divided by 1000. Whatever value come in, just divide by 1000. You will get this value. To melt the ice, to raise the temperature of the copper block by 500 degrees Celsius, then ice can be melted by 1.45 kg for a given copper substance. Now let us take the one more numerical. See here, shall I go for one more numerical? Right. Look at me. Very simple. A brass rod of length 50 centimeter. Shall I take here? Solution I will go directly. A brass rod of length 50 centimeter and diameter 3 mm is joined to a steel rod of same length, same diameter. One brass ada, one steel is joined ಮಾಡೋನು. Same length ada, same diameter ada. What is the change in length of combined rod at 250 degrees Celsius? If the original length at 40 degrees Celsius is there is thermal stress developed at the junction, the end of the rod are free to expand. Coefficient of linear expansion of the brass given, coefficient of expansion of steel is given. See here, two rods are there of same length, same diameter. Which are the material? One is brass, second one is steel. Both are joining by combinedly. See here, this is brass and this is steel rod. Both are combining like this. They are free to expand. We know that when thermal stress developed only when the metal or the combination of metal are fixed between two rigid supports. Here both rods are free to expand because when they are connected it open. First I can confirm you, there is no thermal stress is developed between two rods because Here both rods are connected by freely. What is asking? The thermal stress developed at the junction, then end of the rod are free to expand. Here ends of the rod are free to expand, hence no thermal stress developed. Say here. Let us go for solution. What is given? Shall I take solution? Length is given. How much length is given? Length is equal to 50 centimeter. Length is equal to 50 centimeter. And the diameter is given. How much diameter? 3 mm. 3 mm in 3 into 10 raised to minus 3 meter. Right. The initial temperature is there. Initial temperature how much? What is the change in length of a combined rod at 250 degrees Celsius? When original temperature was 40 degree, I mean T naught given directly 40 degrees Celsius, T given, how much T given? T is equal to 250 degrees Celsius. Right. What I need? What is combined change in length I need? Combined change in length means I need a total expansion due to increase in length. Total expansion due to increase in length. Very simple here. See here, let us calculate expansion of brass and expansion of steel. Comparing both we will see here. We know that the change in length directly proportional to original length and a change in temperature. Alpha 1 represent coefficient of expansion of brass, alpha 2 represent coefficient of expansion of steel. Shall I take here delta 1? Delta 1, alpha 1 is given. How much alpha 1? This is alpha 1 value. How much? 2 into 10 raised to minus 5. L is given 50 centimeter. Keep it up same. Temperature how much? 500 degrees Celsius. Sorry, not 500 degrees Celsius. Change in temperature. Final temperature how much? 250. Initial temperature is what? 40. It is 210. Right? Then shall I go for delta 1? Delta 1 shall I put? Coefficient of linear expansion is like this. Then delta 1 you can find 0.2205. Shall I call delta 1? Delta 1 is equal to 0.2250 centimeter. This is expansion of brass. 0.2250 centimeter. Similarly, expansion of steel we will see. From this equation again write. How to write? Delta L2 is equal to L into alpha 2 into delta T. Right? Again I can call from this delta 2. Delta 2. L is how much? Original length. I will call it as capital L only. See here. 50 into alpha 2. What is alpha 2? This value. How much? 1.2 into 10 raised to minus 5. Delta T. It is 210. Right? Then delta 2 value will find 0.126 centimeter. Calculate just. 0.126 centimeter. This is delta 2. What is combined length? I need combined length from this equation because I need the combination of combined rods. See here. The combination of combined rods, how to write? The combination of combined rod delta L is equal to delta L1 plus delta L2. Right? Shall I put here delta 1 value? Look at me. Combined change in length I need. Delta 1 value is there. How much? Change in length is given by del L1 is equal to del L1 plus del L2. 0.2250 plus 0.126. This may be nearly 0.325, nearly centimeter. 0.325. See students, up to here NCERT numericals are over. Onwards tomorrow we will start the neat part. Thank you.